So here we are with the lecture 4 of electrochemistry. Batteries and fuel cells. Now batteries are classified as two types, primary and secondary. In primary, what happens? They use oxidation reduction reactions that cannot be reversed very easily. But in secondary, what happens? The reaction of these batteries can be reversed. They are rechargeable batteries. Okay. So for example, in primary cell, it is dry cell, Leclanche cell. Here zinc is the anode. Graphite out surrounded by manganese dioxide and carbon is a cathode. There is a paste of ammonium chloride, zinc chloride and MnO2, which is an electrolyte. The cell reaction at anode is, of course, oxidation. That means zinc loses 2 electrons to form zinc ions. At cathode, it is MnO2 plus ammonium plus 2 electrons, that is reduction. Gives you Mn2O3 plus 2 ammonia plus water. The EMF of the cell generated by this cell is 1.45 volts. So I hope the reaction is clear. Okay, let's see the structure of this. So this dry cell battery that you see is a Leclanche cell. Okay, the electrons are flowing from anode to cathode, and here zinc is anode. Zinc outer covering is a gray color covering is a zinc that develops a negative potential, so it is a negative electrode and it is anode. Then you have the ammonium chloride, carbon and manganese dioxide mixture, which is a separator which acts as an electrolyte paste. This is basically electrolyte paste, and the cathode is the carbon positive rod. Okay, so when you connect this to a bulb, the bulb glows because the charge starts flowing. Okay, so anode and cathode are in a compact structure which is known as dry cell or the Leclanche cell. Clear? Reactions we already saw. Okay, next is alkaline battery. So nearly same as a common dry cell, this one, Duracell. So here the reaction at anode is zinc plus 2OH minus plus zinc oxide gives you zinc oxide plus water plus 2 electron. So this is the oxidation reaction that happens at anode on the outer part of the outer walls of the cell, and inside you have, in between you have a carbon electrode which is surrounded by the paste of ammonium chloride, magnesium dioxide and carbon. So there the reaction happens is MnO2 to H2O plus 2 electron gives you Mn2O3 plus OH minus. So alkali is used here, which is actual electrolyte. So you call the battery as alkaline battery. So here the OH ions are being used while here OH ions are produced. This is oxidation and this is reduction. So zinc plus OH ions gives you zinc oxide plus water plus 2 electron. This reaction happens at anode, which carries a negative charge, negative terminal. Then cathode, 2 MnO2 plus water plus 2 electrons gives you Mn2O3 plus 2OH minus. Okay, now mercury battery. So in mercury battery, let's see which is the anode here. The inside there is zinc surface, that is the anode, and KOH saturated with zinc oxide is the electrolyte, and magnesium oxide mixed with graphite is the cathode. Okay, then this is a barrier wall. The gas vent to release the gas. The outer steel covering, inner steel outer top. Then this is tin plated inner top, and sealing and insulating gasket to seal the surface. Okay, so what is a cathode here? Cathode is mercury oxide with graphite. What is anode? Zinc, and which is the electrolyte here? Zinc oxide and KOH. KOH saturated with zinc oxide in the absorbent material is the electrolyte. Okay, so this is the different components which cell is made up of. Then outer side you have a tin plated inner top, then steel covering, outer steel case. Okay, so this is with cell mercury battery. In this, what is the reaction that takes place? Anode is zinc amalgam. Cathode is what? A paste of mercury oxide and carbon. Electrolyte is what? A paste of mercury oxide and zinc oxide. So what reaction takes place at anode? Zinc amalgam plus 2OH minus gives you zinc oxide plus water plus 2 electrons. So oxidation happens at anode. At cathode, what reaction happens? Mercury oxide plus water plus 2 electron gives you mercury plus 2 OH minus. Overall reaction is zinc plus HgO gives you zinc oxide plus mercury. The potential generated by this cell is 1.35 volts. Right? Then secondary battery. What are secondary batteries? So primary battery no longer produce a current when the chemicals inside have reached equilibrium conditions. So when the chemicals gets exhausted, then they don't any longer produce a current. But secondary batteries can be recharged. So original reactant, they can be restored by reversing the direction of the current. Okay, so by using an electric source of electricity, external source of electricity, the reactions can be reversed. Let's see how. So this is a lead storage battery. In this you see there's an anode, there's a cathode. So anode is what? Negative plate. Lead grids filled with spongy lead, and cathode is positive plate. Lead grids filled with and PbO2. Okay. Then the electrolyte here is. So lead plates act as anode. Grid of lead plates coated with lead dioxide acts as cathode. So a solution of sulfuric acid acts as electrolyte. So anode, lead plus sulfate gives you lead sulfate plus 2 electrons. So this reaction takes place at anode. At cathode, lead dioxide plus 4H plus sulfuric acid plus 2 electrons gives you lead sulfate plus water. So the net cell reaction is lead plus lead dioxide plus sulfuric acid gives you lead sulfate plus water. Okay, so this is the anode. This is the reaction for discharging the cell. Now if the cell gets exhausted, lead sulfate gets deposited on the electrodes and cathode, then the cell doesn't work anymore, then it has to be recharged. On recharging, the cell reaction gets reversed. Okay, so nickel cadmium battery. Nickel cadmium battery is made up of cadmium, anode cadmium, plus OH minus alkaline solution is the electrolyte. So this gives you cadmium hydroxide plus 2 electrons. Then cathode is made up of nickel oxide. Then water plus electron gives you nickel hydroxide plus OHs. This reaction happens at anode. This happens at cathode. So what do you see here? There is a powdered cadmium electrode which acts as anode. Then there is nickel electrode which acts as cathode. And there is a separator, and this is the core. Okay. This is the negative terminal and this is the positive terminal. When you connect the two, the light glows. Okay. So cadmium acts as anode, metal grid containing cadmium 4 acts as cathode, KOH solution is the electrolyte. So cadmium plus nickel hydroxide gives you cadmium oxide plus nickel dihydroxide plus water. Cell reaction is reversed on recharging, and the EMF generated by each cell is 1.4 volts, also called the Nicad cell. Okay. Now hydrogen as a fuel. Cars can use the electricity generated by water, by hydrogen oxygen fuel. Hydrogen carried in tanks is generated from hydrocarbons. So in this what happens? This is a hydrogen fuel cell. Hydrogen and oxygen acts as anode and cathode respectively. The place from where you are giving the hydrogen, that side acts as a anode, and the place from where you are giving oxygen acts as cathode. So these are the anode and cathode, the graphite rods on which hydrogen gas is passed from the left side and oxygen gas is passed from the right side. Then there is a porous membrane separating the anode and cathode. Okay. So this is the inlet and that is the exhaust outlet. So cell it can generate 1.3423 volts. This was invented by William Groups. It is an electrochemical device used to convert free energy of the cell reaction to the electrical energy. Fuels used are gaseous states, hydrogen, methane, carbon monoxide, any hydrocarbon can be used. Then it consists of porous carbon electrodes. NaOH or KOH is an electrolyte. Reaction is at anode, hydrogen plus OH gives you water plus 2 electrons. At cathode, oxygen plus water gives you OH minus. So the cell reaction is 2H2 plus O2 gives you 2H2O. So the cell works as long as the hydrogen and oxygen are supplied and the voltage generated is 0.9 volts. Right? What are the advantages of using this cell? It is efficient, efficient than any conventional source. There's no pollution, electrodes are not affected. Okay. Then corrosion. What is corrosion? It involves the slow destruction of metal as a result of its reaction with moisture and gases present in atmosphere. So more reactive metals corrode more easily. Corrosion of iron is called rusting. Okay. So you must have seen corrosion of iron. Iron gets rusted. Iron gets a brown coating if it is kept for long time in the atmosphere. So it reacts with moisture and gases present in the atmosphere and it gets corroded and it forms hydrated ferric oxide, which is rust. Okay. Even aluminium gets corroded, it becomes green, it becomes gray. So aluminum corrosion, how it is different from iron corrosion is that when aluminum reacts with oxygen to form aluminum oxide, that layer that is formed prevents the further reaction. So it forms the corroded first layer of the aluminum acts as a protective layer, which prevents the further corrosion. But then iron rusting is a slow process and it goes on until the whole metal gets corroded. Okay, so mechanism of rusting. Impure surface of iron acts as an electrochemical cell. Pure iron acts as anode. Impure acts as cathode. Carbonic acid acts as a electrolyte. Okay. Now, what's the reaction? See here. So iron gives electrons to form ferrous ions at anode. At cathode, oxygen takes electrons in the presence of carbonic acid, H plus ions, so forms water. So H plus available from the electrolyte. So the net reaction Fe plus oxygen plus H plus gives you ferrous plus 2 water. Now cathode is further oxidized by atmospheric oxygen to form rust. Fe23XH2O. So what is rust? Rust is the hydrated ferric oxide. Okay. So at anode what had happened? Iron changed to ferrous ions by the release of electron. At cathode oxygen reacts with H plus by the gain of electron reduction reaction and forms water. The net reaction is Fe plus oxygen plus 4H plus gives you Fe2 plus water. Now, the presence of salt speeds up the process of rusting because it increases the conductivity of ions. So, iron dissolves, it forms ferrous ions. These electrons produced goes to oxygen, water, water and oxygen plus 4 electron gives you OH ions. So, Fe2 plus further oxidizes to change to ferric oxide. Fe2 plus O2 plus 2H2O gives you ferric oxide plus 8H plus. Okay, and the rust is formed. So rust is nothing else but hydrated ferric oxide. Now how to prevent corrosion? Corrosion can be prevented by barrier protection. Barrier protection is that you apply a coating of the material so that there is no contact between the iron and the air. So that prevents the corrosion. Then sacrificial protection means coating with the more reactive metal that would get oxidized instead of iron. So the process of coating the surface of iron with zinc is called galvanization. More reactive metal acts as anode. Okay, so zinc is more reactive than iron, so it acts as anode. It gets oxidized and iron doesn't get oxidized. Alloying, mixing with a metal that form oxide cores. So cathodic protection. Here metal to be protected is set as a cathode by attaching a more reactive metal like magnesium to it. And now the more reactive metal undergoes oxidation instead of the less reactive, that is iron. Then anti-rust solution, when you apply the anti-rust solution like alkaline phosphate or chromate. The solutions are applied on iron surface to form heat resistant iron phosphate or chromate coating, which prevents corrosion. So cathodic protection, anti-dust solutions, sacrificial protection, then barrier protection and alloy. So these are some of the methods to prevent corrosion. Clear? Okay. So this is how you prevent corrosion. So here you see the sacrificial diagram for the sacrificial protection. It is covered, iron is covered with the zinc. So zinc gets oxidized instead of iron, and oxygen plus 4 pressure fluoride electrons gives you water. So the same reaction, instead of iron, zinc gets oxidized. Okay.